Hey there team, so now we're going to just jump right into sketching, assuming you've watched my previous videos or you were in class and practicing how to sketch sine and cosine graphs at its most basic form, meaning no translations of any sort. No horizontal movement, no vertical movement. In this case here, those are ideal. You just simply do some stretches and it's nice and easy for the graph to draw, right? In this case here, instead of doing one cycle anywhere, they want you to do it between 0 and 4 pi. So that means you only sketch from 0 to 4 pi, and this may be challenging for some, but let's do this together, okay? So we're going to do A. We want to do f of x is equal to negative 2 sine of, and I'm going to write it as half times x, okay? So I can see this here. Now 2 is my amplitude. Remember, amplitude can never be negative. Amplitude is 2. It's the height, right? The negative, on the other hand, is a reflection. Means it flips the graph. In this case, it's a reflection from the x-axis. So it means it flips it vertically. And then remember here when I talked about the period, this is a dilation of factor 2. It's reciprocal. So I'm stretching it horizontally. I'm making it wider. So that means the period's going to change. So the period, which normally is 2 pi, I'm now multiplying by the reciprocal of half, which is 2, which is why it's 4 pi. Or if you prefer, you could have wrote as 2 pi on n, and that's 2 pi on half, which is the same thing as 2 times 2, which is 4 pi. Okay, so how do we sketch this? So if we were to sketch this, I'm probably going to do it with an actual axis. Oh, that's terrible. Not that one. I wanted this one. Okay, so if we were to sketch this now, here we go. It says from 0 to 4 pi. Okay, cool. So I only want to do from 0 to 4 pi. Let's say 4 pi is there. They tell me that the period is already 4 pi. So that's great. It means that I'm going to fit within the cycle. It's a sine graph. So I know that sine graphs normally start at 0 and it goes up and it goes back down, right? So that's pretty nice and easy. But notice there's a negative in front of the 2. That means it's a reflection. So instead of it going up, it should now be going down, right? So that's roughly what my graph looks like, but that was only to deal with a period of 4 pi. So to do one cycle, I should go all the way down, all the way up, and then come back exactly at 4 pi. That's one cycle, okay? So that means the center here has to be the halfway point, which is 2 pi. And what else do I know? It tells me the amplitude is 2, so that means from here to here is a distance of 2. So that means my maximum height is 2 and my minimum height is negative 2. Look how easy that was. Y, X, and there we go. That's my perfect graph. Don't put the 2 in though. I'm just doing it for you to understand. Okay? And there you go. That's my graph, 0 to 4 pi. So you would have thought, well, that seems pretty easy. Like, why was this tricky? It's only tricky when you start doing multiple revolutions. In this case, they only got you to do one nice cycle between 0 to 4 pi. Part B is where it kind of challenges you slightly. Okay, so let's do B, which is y equals negative cos of 2x. And when I say challenges, it only challenges because we're not yet used to sketching circular functions. But over time, you'll love to sketch these type of functions. They're so much easier to do. Okay, so here we go. Let's go through the same process again. What do we have? We've got a negative. Negative doesn't do anything but a reflection. Okay, so this is reflection. But what's the dilation? Okay, what's the amplitude? Well, clearly it's a 1. Even though you don't write it, technically there is a 1 there. So I know the amplitude is equal to 1. So that's nice. It hasn't stretched vertically. It still stays as 1. But the 2 here, this is a dilation factor of the reciprocal of 2, which is half. So that changes the period. It means that I am compressing it horizontally. I'm compressing the graph to now a period of half of its normal length. So normally it's 2 pi. I'm now timesing it by the reciprocal of 2, which is half. So that's why it ends up being pi, right? Or if you prefer, you can write it again as 2 pi on n, and that's 2 pi on 2. Cancels out to be pi. Up to you. Whatever you want to do. Okay, I'm trying to teach you to understand dilation factors. That's why I write it that way. Okay, you can use the formula if you want, 2 pi and n, and that works the same way. So here we go. We've got a period of pi. So if I were to roughly sketch this, I now know to do one cycle, it is pi, and I know that the amplitude is 1 and then negative 1. So height is 1 and bottom is 1. True? So then how does that change in terms of the perspective of all things? Well, say again, this is 0 and I only want to sketch up to 4 pi. Now, you see, to do one cycle, one cycle only takes me to pi. So that means if I sketch it, sorry, that's a sine graph. Well, what graph do I have? I have a cos graph. Whoops. Let's do it again. Cos graph means I start off here, and oh, notice there's a reflection. So actually I start off down here now. Woo! Almost got me. There you go. So that's my cos graph for one cycle. So that means when I sketch it now, this is the one cycle from -1 to maximum 1. I normally don't do the amplitudes first. I normally just sketch it first and then I label the amplitude. So that's one cycle, right? But we want it to be pi. So I'm going to try to split this into quarters now to make it sort of more visual. So there are 4 of these pi's that fit into the 4 pi domain. So that means when I sketch it, it has to then fit within that realm. There we go. This is now the pi. That's one cycle. Then I have another cycle. Goes up, comes back down, and I finish that again. So that's now 2 pi cycles. So 2 cycles, and it goes all the way up and all the way back down again. And that's the minimum. That was a terrible one, actually. So let's do it again. And there we go. So that's at now 3 pi. And then finally I get another cycle and I finish off at 4 pi. Okay, so that's the main difference between it. Technically, we are meant to find the x-intercept, so we haven't started plotting that Intel graphs. That's now for 4i, 4j. That's what makes this tricky. Okay, I haven't even moved this graph left, right, up, and down. That's what makes this whole process insane, because there are a lot of moving factors here. Okay, so that's what this part is. This is the only time it makes it tricky, is when you have a smaller period than the actual domain. The number of cycles you make has to make sense, and sometimes it doesn't have to fit nicely. Sometimes they could just say from -pi to 2 pi and 3, and you have to be able to sketch it with the correct endpoints, with the correct maximum, minimums, and number of cycles. That's what makes this hard. Okay, but that's for 14i and 14j for you to sort of get your head around later on. But at the moment, that's what you're practicing as this last example to get you going. Okay, so these ones are easy. These ones will start to challenge you a bit more, but it's only stretches. There's no translations yet. Okay.